Hey everyone, welcome back. Today we're going to look at quadratic inequalities in one variable. Right, so we have a quadratic here, inequalities, and only the variable x, like that. So one variable quadratic inequalities. If you've completed the intro video and the other quadratic videos in this playlist, then today's lesson will be a lot easier for you. So in this lesson, you may round your answers to 2 decimal places. And so let's get started. Example 1, determine the solution region of the inequalities. So here we have our first inequality, A, x squared minus x minus 2 less or equal to 0. So the first thing we're going to do is determine when it is equal to 0. So we're going to factor, right? Product -2, sum is -1. The two numbers are -2 and 1. So we have x minus 2 times x plus 1 equals 0, like that. What do you plug in to get 0? Those give the x-intercepts, so 2 and -1, like that. And so here at -1 and 2, these are the x-intercepts. The y-intercept occurs when x equals 0, so we plug that in here, we get y equals -2, like that. And so this is a rough graph of our function. And I like to think of inequalities of this format to be when is the function less or equal to 0, right? So this is a quadratic function, y equal x squared minus x minus 2 as a function. When is the function less or equal to 0? And on the graph we can see it. It's this area here, right? This is below the x-axis, like that. And so it is negative or equal to 0 between -1 and 2, like that. Right, so I'm just going to read that here. From the graph, we see that the function is less than 0 between -1 and 2. And so that's our solution region. X is between -1 and 2. And it's allowed to be equal because it's allowed to be equal right here. So this is the answer, solution region, like that. And graphically, though, it looks like a number line. From -1 to 2, like that. This is the solution region, like that. So right here, like that. That's our solution region. When is the function below 0? Like that. Okay, let's do another example. Example B. When is the function greater than 0? So we're going to factor out a -1 here, like this. And then we're going to factor this quadratic here. So product -3, sum of 2. Those two numbers are 3 and -1. And so we can rewrite this as -1 times x plus 3 times x minus 1, like that. When is it equal to 0? It is equal to 0 at -3 and 1, like that. And so this is super handy to have. This little line like this is going to be -3 and 1, like that. And so what we're going to do is test points from different regions here and see which ones are greater than 0. Right, so you want to take very simple ones. So we could go -4, 0, and 2, like that. So we plug in -4. We get -5 greater than 0, which is false. So this is not the solution region. If we plug in 0, we get 3 greater than 0, which is true. So this is part of the solution region. And then when we plug in 2, we get -5 greater than 0, which is false. And so here you go, it is not the solution region. So we see that it is the solution region between -3 and 1, like that. And so that's our solution region. X is between -3 and 1. Okay, example C. Quadratic greater than 0. So first we'll get the x-intercepts. When is it equal to 0? We're going to use the quadratic formula. A is 1, B is 2, C is -4. We plug all that in. Here we have root 20. Just a reminder, root 20 is the same as root 4 times 5, is the same as root 4 times root 5, is the same as 2 root 5, like that. So this is side comment how we got from there to there, like that. And so we have -1 plus root 5 and -1 minus root 5. And so this gives us our 2 intercepts, like that. And so we're going to write that on our line as such. -3.24 and 1.24, like that. So we're going to grab test points and check them all. So we're going to have -4, 0, and 2, like that. Right? So we're going to have these 3 test points. We plug it into, we plug -4 into our quadratic, right? Up here, we're plugging in -4. And we get 4 greater than 0, which is true. So this is part of the solution region. X equals 0, plug that in, we get -4 greater than 0, which is false. So this is not the solution region. Plug in x equals 2, we get 4 greater than 0, which is true. And so this is part of the solution region. And so graphically, this is what it looks like here. Less than -3.24 or greater than 1.24 like that. And so that is the solution region. And notice that it's an empty hole here because you're not allowed to be equal. If it's equal, you fill that hole up. Okay, time for some practice. Practice number 1. Determine the solution region of the inequalities, A, B, C, and D. Go ahead and pause the video and answer that. Okay, we're back. A, when is the function less or equal to 0? We're going to do some factoring. Product -15, sum of 2. The numbers are -3 and 5. Therefore, this can be written as x minus 3, x plus 5. When does it equal 0? At 3 and -5 like that. So we have our line as such, so -5 and 3. We're going to do some test points, -6, 0, and 4 like that. We're going to plug it into our factored version here. So -6 gets plugged in, 9 less or equal to 0, that's false. Plug in 0, we get -15 less or equal to 0, which is true, so we update that here. Plug in 4 and we get 9 less or equal to 0, which is false. So we update that here. So this is our solution region. So between -5 and 3. And it's allowed to be equal because it is less or equal to 0, like that. Okay, B. X squared minus 3 greater than 0. So first we're going to find out when is it equal to 0. We're going to use our quadratic formula here. We get plus or minus root 3, which is approximately 1.73 or -1.73. So we update that on our line here. Oh, just a quick comment. Root 12 is root 4 times 3, is root 4 root 3, is 2 root 3 like that. So we're going to use test points -2, 0, and 2 like that. Simple numbers. When we plug in -2, 1 is greater than 0, so that's good. When we plug in 0, we get -3 greater than 0, which is false, so not that section there. When we plug in 2, we get 1 greater than 0, which is true, and so it is that section there. So the solution region is x less than -1.73 and x greater than 1.73. Okay, C. When is the function here less than 0? So we're going to get our x-intercepts using our quadratic formula. A is 1, B is -2, C is -4. We get root 20 here. This becomes 4 times 5, root 4 root 5, 2 root 5 like that. So just a little comment here. So we get 3.24 or -1.24. So we update that on our line here. Test points, -2, 0, and 4. Very simple. Plug in -2, we get 4 less than 0, which is false. So we update that here. Plug in 0, we get -4 less than 0, which is true. So that's our solution region there. Plug in 4, we get 4 less than 0, which is false. So it is not that section there. So the solution region is between -1.24 and 3.24 like that. D. -x squared minus 1 greater or equal to 0. So this one's easy to graph. So -x squared minus 1, so it goes down by 1 like that. So that's our graph. We notice that the function is never above nor at 0. So the solution region is the empty set. And that's it. It's that easy. I'll see you guys in the next video.